Um, Hello everyone. My name is Kyla Kim and I am zooming in from South Korea today. So my instructor for this entire research project was Dalton George, and he really warmly guided me through this entire process, which I will forever be grateful for. And for his passion, patience, and guidance, that was the reason I was able to succeed on this project. And after months of very grueling hard work, I'm very excited to share my results and progress on this project, which is regarding the industrial symbiosis and circular economy based on the textile industry with considerations of multidimensional aspects, especially as a regional focus in South Korea. Okay, so that was quite a mouthful to say, but you might be wondering why I got into this topic in the first place. So it all started when I started looking at these headlines. Europe sells to Africa and Asia 90% of its used clothes. The garment industry is ignoring the plight of its workers. When I looked at these headlines, I first of all thought of how I had always turned a blind eye to the wasteful and unethical nature of the textile industry itself. And that was especially because I had a culture of nonchalance towards fast fashion because I was in South Korea. And in my country, fast fashion is quite prominent. And fast fashion here is when people buy clothes due to the fad, just to follow the trend, wear it, and then dispose of it very quickly, which results in these monstrous mountains of textile waste as shown in these images over here. And even though I was quite aware of how textile waste was a problem in my country, I didn't know the extent of this problem. So in order to dig into it a bit more and hopefully to find a solution, I constructed a process of inquiry. And yes, as for most papers, I started with a literature review. And I had these two research questions constructed, one mostly conceptual about like what the circular economy is and how is it reinforced in the textile industry. But the other one was more regionally focused and more solution focused. What dimensions could I focus on and how could I discover these different dimensions? And I split them into 5 analytical categories with the help of my mentor, and I started digging into the research. And I mainly used about 20 to 30 sources of information, mostly from Science Direct and Google Scholar. And by annotating these research papers, which ended up being more than 60 pages of annotation, these are the highlights of my socioeconomic effects of the textile industry that I didn't quite know about before. And probably you didn't know about before either. So during the rise of fast fashion, the energy consumption of the textile industry, which I did not know had this much energy consumption, actually rose by 29%, whereas the greenhouse gas emissions, which are basically like carbon dioxide and methane that warm up our planet, rose by 23%. And 93% of the fashion companies that we buy from do not pay their workers even a basic living wage. And greenwashing, which is actually a process that a lot of companies use, especially in the textile industry, is very prominent in the textile industry. And greenwashing is basically a process in which the companies deceive the customers into believing that they are using eco-friendly and green processes when in fact they're really not. And as much as 70% of the textile waste, as you can see in these pictures, are actually sent to Africa or other low-income countries, which brought up a lot of issues in regards to inequity. So that was a lot of basic research that I dug into, and I started to realize just how much of both a regional and global issue this was. But I also wanted to focus on what the solution was. And as an environmental activist, as I'm quite passionate about sustainability already, I had heard of this term before called circular economy. And let me just quickly explain the difference between linear economy and circular economy. So linear economy is the system that we use nowadays, well, still. So I'm just going to give an example with this notebook. This is just a random notebook. But nowadays we take, for this notebook, we take trees as a resource to make this notebook. We use the notebook, we make it, and then we just throw it away. We dispose of it. That's a linear economy. But it's very obvious that this is very wasteful, not just environmentally, but also economically, because once you make this notebook using the trees, which actually cost money to grow, you just throw it away. It takes up space in the landfill and it also pollutes the surroundings. So it's a lose-lose situation. So the linear economy is very bad environmentally and economically, but it is very prominent in almost all industries, especially the textile industry, as I just explained with fast fashion. But circular economy is basically the same thing, except for at the end, instead of disposing the product, this product is transformed into a totally different product that can be used for other purposes. For example, this paper may go into a different form of a product, and it's called a value-added product, where waste is made into a new material. And this seemed to tie in perfectly with another big concept that is currently on the trend in sustainability called industrial symbiosis. And as the name suggests, symbiosis, it's basically a process where two industries or multiple industries form a network for each other, and then they help each other to get rid of the waste and also to use up resources, saving both economic profits and also in terms of environmental resources. Symbiosis is a biological concept, actually. It's usually when two organisms basically mutually benefit each other. But in this case, instead of organisms, it's industries. So this graph pretty much sums it up pretty well, but I'll go into more detail on it later on. So basically, for me to conduct some further research, I actually went to a regional center. I was really excited to find a place called the Seoul Upcycling Center, which by its name already suggested that it might use like a circular economy or have a similar concept. And I've also researched before this site visit that they focused on textile waste and making them into value-added products. So I was very excited. But when I conducted the site visit, I'm sad to say that I was quite disappointed because there was not a true application of circular economy that I could observe, because mostly they had scraps of clothing and textiles that were donated from other private sectors or private companies from South Korea, but they were mainly used for art exhibitions, and they were mainly modified here and there a little bit so that they could be displayed in exhibition, only to be basically disposed of later on, which is not truly a circular economy because it's just basically used as an art project and then disposed of. So I was quite disappointed at that because there was no real economic incentive. There was no saving of resources, nor was there the sparing of the waste. Nor was there sufficient funding from the government for this very project, which was why I believe there were less technical procedures than I thought there would be. And this is because I found some very intriguing technical procedures that I found in my research. First of which is a chemical approach, and it was for cotton PT blended fabrics. And the main problem for these clothings are they can't usually be biodegraded or just abandoned because of the PET part, which is basically plastic. And because these PT strands and cotton threads are mainly integrated together, it's impossible for them to separate. However, that is not the case for this process when you use something called mercerization. And mercerization is a chemical process where you use an alkali solution to basically loosen the strands of cellulose, which is basically the cotton, if I'm explaining in layman's terms. And in this case, the alkali used was sodium hydroxide. And using the sodium hydroxide, as you can see from the optical microscopy over here, there were these holes that were created in which the PET and the cotton, the cellulose, were separated. And after they were separated, they went through something called enzymatic hydrolysis, which is basically like a fermentation process. And in this fermentation process, using sulfuric acid, there were two main products, TPA and ethanol glycol. TPA is basically a precursor for plastic, so when this precursor was made, they could basically be recycled back into the plastics industry. So then, as I said, industrial symbiosis right here. The textile industry had a waste product, which is now a resource for the plastics industry. Or for ethanol glycol, it's used in antifreeze, which is used in the automobile industry. So in this case, the textile industry and the automobile industry. So here we can see the true application of industrial symbiosis. And over here you can see how the fabric pieces keep on disintegrating into further electron microscopy until it barely leaves any skeleton structure because it has been dissolved into these byproducts. And this second biological solution is for wool PT blended fabrics, which is a different category. So basically, the wool is first of all degraded with proteins because wool has keratin fibers, which is a type of protein, so it can be degraded with proteins. So after it is degraded with proteins, it is then mixed with something called sodium thioglycate to produce keratin hydrosylate. And this keratin hydrosylate is often used in hair products, actually. So here we can connect the textile industry with actually the cosmetics industry, which is also a very interesting connection. So here we can see a very valuable usage of industrial symbiosis. So the technical aspects play out, but how about the real life context, or how about the business part, right? So here's the system that I figured could be designed from this. So after the product is made over here, after the clothes are made and the products are sold, here we can see it's a little bit of a help from the diagram. The blockchain system can be integrated. And I know that's quite a lot. And the blockchain system is usually integrated for the financial sector. But its main advantages is that an item can be tracked as a block and it has a specific identity called a hash, so that it's also immutable, which means the block cannot be changed or removed, so the transactions are always secure. So what is its role here? As I said, greenwashing is a big problem in the fashion industry. And if a block is created for every product that is created, then it means that the process of which this clothes were made and the materials used or the carbon footprint can be steadily recorded in each of these blocks, which means it can prevent greenwashing. And after these products are sent to the waste, it can be split into two categories, whether it's con PT or wool PT through AI and image processing. And through this process, we can make sure that the byproducts that are generated are also generated through a block. And these hashes can then be traded through different industries. For example, beforehand, I gave you an example with the textile industry and then the automobile industry. So let's say the clothes was made into some ethanol glycol that could be used in the automobile industry. Then this can be posted in a blockchain, a block, and and companies in the automobile industry can view these blocks and actually can purchase from and trade from this textile industry. So it basically creates a chain of trade, which can also kind of look like a circular model, which basically reflects on the whole circular economy and industrial symbiosis concept. So then that is actually a very efficient system and can reflect on the sustainability of these products. But the real significance here is how willing are people and corporations to integrate the system into their real life, and how fast can fast fashion, pun definitely intended, can be erased as a cultural norm in our society. And sustainability is almost like a reflection on human society, because right now we are reevaluating the systems that we've trusted and used for hundreds, even thousands of years. And we are just now noticing that some of the systems that we've used just aren't compatible with the sustenance of our future. So of course, we are taking small but sure steps, and as a high school freshman, I have taken my own step to evaluate the textile industry, which I've seen as one of the most prominent regional problems that aren't compatible with the future anymore. And I tried to find some connections, some solutions to it through scientific and technological dimensions. So the main message is this: by looking at the idea of circular economy and industrial symbiosis, we can change the sustainability of our world one system at a time. And we must connect our systems as a symbiotic process to improve the sustainability of our world. So that is the main message of connecting this topic with economics and sustainability. But yes, thank you.
Thank you so much, Kyla. So there was a question that came in actually from one of the mentors prior to your presentation. And the question is, can you envision what might be some of the downsides of the solutions that you've proposed?
So that is actually a very good question because a pro-con analysis is always needed in these types of situations. I would like to go back to one of the solutions I proposed, which was the biological one, and it used something called protease to break down the keratin fibers inside the wool. The protease name is something called rhodozyme proact. And rhodozyme proact, since it's a biological product, it's an enzyme, it definitely has sort of like a period of time where it's in its prime efficiency and an environment that it's supposed to be in to have its prime functionality. So for these types of products, it's hard to incorporate in industrial settings or even incorporate them into large scale settings because it's quite hard to maintain these settings. For Rhodozyme Proact, you would need an optimal temperature of 37 degrees at all times, and it has certain humidity levels that need to be obtained. And this can be quite energy consuming, and if it's gone the wrong way, can actually fire backwards and end up being less sustainable than intended, actually. So in these situations, yeah, it can have some disadvantages. So that's why a lot of the researchers are trying to see if certain enzymes can be adjusted so that they require less supervision or less of a preferred environment and are more flexible with the environment that's given. But yeah.
Thank you for that answer. And then just one last quick question. What would you say was the most difficult part of your research?
The most difficult part was I actually felt it throughout giving the speech as well, and even throughout the research paper, but there are just so many aspects, especially because it's multidimensional, socioeconomic, political, ethical. That's already like 3 to 4, but then I've added in scientific and technical, and it was sure a mouthful to say. But sustainability in itself is like a multidimensional issue. It's such a big scale issue that it was really hard for me to fit it all into one research paper, and more or less, it was hard for me to process it all in my brain as well. And I can only imagine how hard it is for people to process this, the general audience, and for them to feel if as if this topic of sustainability is too complicated for them to solve. So I guess that was one of the biggest challenges. Is this like it's definitely not an easy topic. So yeah, I guess that was the most difficult part.